and welcome everyone. So in this episode, we are talking about wear location, the device placement in studies, mainly talking about the accelerometer, but also other signals, and that you need to match the device placement to research goals. Sounds like very natural, but I think it's quite often not maybe thought through enough. And for researchers, choosing the right wear location for a device is essential to capturing study specific data accurately, and mapping the wear locations to study objectives helps ensure that the most relevant metrics are detected, enhancing data quality and making analysis more meaningful. So we will look why versatile wear options are important in research and how devices with flexible placement, like our new Fibion Flash, allow research to match device location to each study's needs. And this versatility not only improves data relevance, but also this versatility of device not only improves data relevance, but also serves as a valuable investment, allowing the same device to be used across different studies and different research groups. And choosing the right placement for a device make it possible to gather the most accurate data for a given research objective. For example, if the primary goal is to monitor sedentary behavior, you should have the device on the thigh, because then you can actually measure the orientation of the thigh from the sensor orientation. So you can actually really measure that whether the person is sitting or standing, and then you get an accurate physical activity intensity measurement meant from there. Sometimes for the convenience reasons, people are wearing a wrist-worn device and they make conclusions about sedentary behavior. That's pretty okay. You get the no movement and movement times, and no movement is kind of sedentary most of the time, but the person might be standing. And especially, for example, people with higher body mass index, the standing quite a bit of muscle activity. So it's not really sedentary behavior. So that's, for example, for the sedentary behavior and physical activity measurements. Then if you are interested getting also other signals, for example, there's a lot of interest for heart rate variability, as it gives a nice indication of autonomic nervous system balance, and from it you can naturally calculate heart rate. And when you're using an accelerometer, you get only the absolute intensity of activity, meaning that it doesn't know how much is it for this person. It doesn't know the person's fitness. It's not in relation to the fitness, and this leads to the thing that you might measure that vigorous intensity activity, but for a very fit person, it's not much, and it doesn't really provide stimuli for improvements, while even moderate intensity might be a large stimuli for improvements if you are very unfit. So combining accelerometer and heart rate measurements gives you both the relative and absolute intensity measurements, and I think those both are important. And you can measure the heart rate with the PPG sensor from the wrist. But if you want the more accurate, especially heart rate variability measurements, you should measure it from the chest, and then you can use chest belt or electrodes. And then you also get the acceleration of the torso, and you can detect from there also, for example, walking and non-movement times. So comparing that, whether, for example, you want to measure where the device on the thigh or on the chest, from the thigh you get a little bit better data for sedentary behavior and physical activity, absolute intensity. But then if you want also heart rate variability or the relative intensity, then the recommended position is on the chest, that you can also get those. And the ECG heart rate variability is very good for studies where you're interested of stress response, recovery, or cardiovascular health. And also when you attach it on the chest or on the torso, it allows research to capture body position during sleep, or for example, you can assess gait symmetry or balance related metrics when you place it centrally on the chest, so you can actually see the swaying of the body, and possibly some kind of balance related metrics which are important in studies of motor control, postural stability, and for example fall prevention. And with our Fibion Flash, we have made it very easy to change the position of the sensor. So it has snap connectors in the bottom. So I can, for example, just clip it on my wrist. So it's in the wristband. Participant can detach it and attach it on the chest belt. So, for example, you could wear the device uh, on the wrist or on the thigh in the waking hours, and then for the night time, you could attach it to the chest to get good ECG and heart rate variability data. So, this kind of snap connector or easy removal and attachment of the device enables also a little bit more innovative research designs where you can get different data from different parts of the day, and still you will need only one device per participant for each measurement wave. So it gives a bit more flexibility in the study designs. And maybe one more feature that is worth mentioning: for the Fibion Flash, we also have textile integration. So we have a easy way that you can just attach it to the clothing. So basically you attach the opposite part of the snap connector into clothing, and it's pretty easy. And then the participants can just snap on the device on this part. So gives a little bit more, again, flexibility and a little bit more possibilities for research design when you can use this textile integration. And maybe when we talk about the attachment, usually we only think about which body part we should attach the device. Maybe good to also think that you can also sometimes put it outside of the body. So for example, if you're doing research, sport research, you could attach the sensor, for example, to tennis racket or golf club. And as the sensor is only 10 grams, it doesn't make a big difference in the technique, and you can get the motion of the sport equipment. And for example, you could have one, for example, on the arm and one on the racket golf club, and you could, for example, compare that. How does the acceleration increase, for example, due to the whiplash movement of the wrist? And also, if you think different application, for example, occupational research, you can also have the sensor on, for example, a vehicle. Let's take example that you have a bus driver and you want to study the low back problem, low back loading of bus drivers. So you could attach one on the car under the driver, and then one, for example, on the driver, and you can study the. They usually have a dampening system in the seat of the car that you get less loading. So you could, for example, study the different dampening systems in these seats when you compare these two acceleration signals between these two sensors. And yeah, with the small sensor, you can do many different kind of research settings. And when you have devices that can be worn in different parts of the body, you have customizable settings, and you have different adapters to wear the device on different parts. It improves the adherence, so you will get the better data set, but also that you can use it in many different kind of projects. So you can use in different projects, and other research teams can use the same devices, so making it a better investment. And if you have any questions about this topic, feel free to be in contact. And if you're interested about Fibion Flash, check our website or book a call with me or Dr. Miriam Caprita. We're glad to have a chat and see if reply any questions you may have and see if our solutions could be good fit for your projects. Thanks for listening and have a brilliant day.